Okay, here's a little help on the mole lab. Since it's going to be a little bit difficult for you, just kind of getting some of the terminology together. So I thought I'd put this together for you to help out. Now, the first compound in that vial that I showed you was some sodium bicarbonate, and it was a white powdery substance. And on the outside of the tube, there was a label that had a certain amount. And then we put that whole entire test tube with the sodium bicarbonate on the scale, and we masked that, and then we could take the difference to find out the compound. Now, I made these values up, so please do not use this value. Use the value you had in class. So let's pretend that the vial had a label on it that said that the test tube, the vial, and the cork and everything was 6 grams. And then we took and put that on the scale, and we got 8 grams. We subtract out the test tube, the cork, and the label, and we get 2 grams. Now that's 2 grams of sodium bicarbonate. That's how much was in this test tube. Now there's a couple things that I want you to keep in mind. That is a lot of formula units. Why do I call it a formula unit? I'm sorry. I'm not at my Promethean board, so it's a little difficult for me to write using my computer. For why do I call that a formula unit? Because it's an ionic compound. It's starts with the metal, and it's ionically bonded. So we can just call that a formula unit. Now, yes, absolutely, for every one formula unit, there is 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygens. But be very, very cautious to ever put those values down if I'm talking about how many are in this test tube, because obviously if there was only 1, 1, 1, and 3 of those, I couldn't see it. You couldn't see it. Nobody could see it. And so just be very careful with that. Now we're going to do a couple conversion factors. And the very first one that we need to understand is where I'm going to get my molar conversion. A molar conversion is the addition or the sum of all of the atomic masses off the periodic table. So if I looked upon the periodic table and I found the molar mass of sodium bicarbonate, that would be sodium's 23, and hydrogen is 1.01, and carbon is 12, and oxygen is 16, but there's 3 of them. If I added that all up, I'm going to get a molar mass of 84 grams for every mole. Meaning if I had a mole of sodium bicarbonate and I put it on the scale, the mass would be 84 grams. Well, we already know we only had 2 grams of this, and that's absolutely impossible to have a mole there because it's significantly smaller than 84 grams. The second conversion factor that we need to make sure that we understand is if I took a mole of sodium bicarbonate and I put it on the scale, absolutely right, it would have a mass of 84. But how many of these sodium bicarbonate formula units would I have? Well, for every mole, I have Avogadro's number, or 6.02 times 10 to the 23rd formula units, or representative particles. And so there's another conversion factor. And then last but not least, for every one of these formula units, I do have 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygens. So if you understand the conversion factors that are playing into this, we can answer any of these questions. So let's just start with question number 1. If I start with 2 grams of sodium bicarbonate, and sometimes it's best to write down what you're talking about gram-wise. Well, in this case, I'm talking about how much sodium bicarbonate was in that test tube. I had 2 grams. Now, I need to realize that the conversion factors that I have is the molar mass and then the Avogadro's conversion factor. So, first thing I need to do is convert my grams to moles by dividing by the molar mass. Because that gives me how many moles are in that vial. 2 divided by 84 would give me the number of moles in the vial. And then from there, because I want to get to the sodium atoms, how many of these sodium atoms were in that tube? I'm going to convert my moles to formula units, or using Avogadro's number, that will tell me how many of these compounds are in there. So that tells me how many I have. And then from there, I know that the ratio for every one is going to be a 1-to-1. Meaning for every 1 sodium bicarbonate formula unit, I'm going to have 1 sodium more. And that cancels out my formula units. And when I'm done, I'm going to have the number of atoms. And if you multiply that through, it's going to be a huge number. And rightfully so, because in order to see the actual compound, I'm going to have a significantly large number of atoms. Now, the only difference between question 1 and 2 is that I'm not talking about sodium anymore. I'm just talking about hydrogen. And again, for every 1 sodium bicarbonate, I'm going to have one hydrogen atom. So I go through and I convert my grams to moles, and then I convert my moles to formula units, and then I convert my formula units to hydrogen atoms because it's a 1-to-1 ratio. And likewise, carbon, the same thing. Again, I'm going to convert my grams to moles, my moles to formula units, and I know for every 1 sodium bicarbonate, I'm going to have 1 carbon atom. And so far, for every sodium bicarbonate formula unit, I have the same number of sodium atoms, I have the same number of hydrogen atoms, I have the same number of carbon atoms. The only difference is when I get down here to the question of oxygen. And that is because for every 1 formula unit, I'm going to have 3 times as many oxygen atoms. And so I think that's pretty clear. And if you have questions, we can keep working through that. Now, how many moles? I mean, maybe it would have been easier if I added this question first, because I'm just going to convert the grams, 2 grams of sodium bicarbonate, which were in the tube, to how many moles. And I used the molar mass. So grams divided by the molar mass is going to give me the number of moles of sodium bicarbonate. And that's a pretty basic, easy one right there. Just remember, that's what the average atomic mass on the periodic table helps us to do. It tells us how many, what the mass is for 1 mole of that element or compound. And then last but not least, how many formula units. So after I converted my grams to moles, I know for every 1 mole, it's going to tell me I'm going to have Avogadro's number of RPs. And in this case, an RP is a formula unit because it's an ionic compound. Formula unit can be an atom, it could be a formula unit, it could be an ion, or it could be a molecular compound. So like water is a molecular compound. And so that should help clear up some confusion. Now be careful on the rest of the questions. They're asking almost the same types of questions, but I might ask a little bit more different. Just be aware of what types of questions are being asked. And if you still have questions, you can email me or come and see me in tutorials. Hope you have a good weekend. Bye-bye.